let's continue Advent of Code Day 7, Part 2. Now you're ready to choose a directory to delete. The total disk space available to the file system is 70 million to run the update. You need an unused space of at least 3 million. You need to find the directory you can delete that will free up enough space to run the update. In the example above, the total size of the outermost directory, and thus the total amount of used space, is this. This means that the size of the unused space must currently be this, which isn't quite this that is required to update. Therefore, the update still requires a directory with total size of at least to be deleted before it can run. To achieve this, you have the following options. You can delete any one of these directories. Directory E and A are both too small. A couple things. We have to get the total size of the root dir first, and then we need to determine for AOC2, this is just getting our total size, and we really should be calling this build tree, which takes in the string, and then we can change this to we want to return we know it's going to be a directory. Why we mess around? Okay. So now AOC, the first AOC is just going to take in which is a directory, and that's that. And then we change this to be roots and roots. Okay, so that's pretty much the same because we want to build that tree, but we want slightly different logic for the calculation. So we're going to do dir to delete. Let's call it AOC2. It's fine. Let's go back to the input text for a second, because they want, find the smallest directory they've deleted would free up enough space. What is the total size of that directory? Okay, so we just need the directory size. So a couple things. This is kind of messy. I'm just going to put it right here. AOC2. We're going to get in a root directory, and we're going to return an int. Okay, and so the first thing we want to do is our needed size is this. Okay. So that's our update size, and then set how much space needed for the update, and then all we should have to do is root.size needed space dot size minus update size. Okay, so that's the directory. That's the amount of space that we need. So now, so what we can do is just, again, some recursive functions. Smallest or above size. So smallest or above size. That's a great or above size. Great function name, right? So we're going to get the directories. Yeah, let's do this. Smallest. Okay, so we're going to just do this. We're going to simply say if d.size less than or equal to s smallest equals s d. We made the same mistake last time, right? So we're going to range over the directories. And actually, we want the size to be greater than or equal to the size. And iterate through, and we're going to say okay, so we're going to loop through each directory, and then we're going to return smallest. Okay. Suppose I could do this one before or after, but that should give us the recursion that we're looking for, and it should return that, which we can do a dot size on. Okay, so we're going to recursively call this. Yes, I know we could potentially end up with a nil, and this is not really great practice here, but don't care. Okay, so in theory, this should all work. Yep, I did change that. So what was that function called? Build tree. Build tree. Got it. Root. Build tree. Okay. And then we can pass root here. And then the, going back here, the okay, so that means that we should perfect. All right, test results are done. Same input. So all you have to do is go run go day 7, get our new result. Okay, I did something wrong, but it worked in my test case. So here's the problem that I ran into, and this This is what I love about Advent of Code, is that the problem case, a lot of times I feel like they intentionally make it so that if you use TDD, you're going to pass the test, but then there's going to be something you didn't quite pay attention to. I don't know if that's intentional or not, but here's the issue. I'm merely getting the total amount of disk space, and I'm subtracting 30 million. So what I should be doing is taking 70 million, which is the total size of the file system, minus the used space, which puts me at, like if I just use this example, this minus this minus this means I only need 8,381,000, which is more than this, but less than this. And so that's why my test case passed, because I didn't do that equation. So what I really need to do is figure out how much actual space I need. So the reason this is not working is because my needed space is wrong here. So I know that my equals 70 million, sorry. And so if I subtract it's possible this could be a positive number, at which case, or rather a negative, in which case I have plenty of space. But again, I don't think that's the problem here. So I'm going to run this again. Should still pass. And then if I rerun this, I get a different value, which I don't even remember what my last value was, but that's still not right. That didn't change my value? I think it should have. Okay, let's look at our test input again. The total disk space available to the file system is this. To run the update, you need update space of at least this. Total size of the outermost directory. But at least. Okay. Okay, I feel like I think that was it. There we go. That's right. Okay, awesome. A little bit of bugs, a few bugs here and there, but that's okay. That's why we test. It's kind of important, although it's a little hard to generate additional test cases with this data. Although we could, that would probably take more work. But it's important to kind of point out that one test case isn't really good enough. Especially in this case, we have multiple lines and we have multiple input that show that we could build the tree. But to make sure that we were getting to the right result, one test case isn't enough, but we got to figure it out. So, all right, well, that's it for tonight. I will talk to you guys later.